I'm going to do 5 minutes without a slide. Thank you so much for all that information. There's a conversation that needs to be had. I agree with you in a major way. And the reason I would like to just speak for 5 minutes is to just give you my point of view. So I'm entering my, how many people here in the electrical sector? Oh, we got a few. That's good. So I'm entering my 40th year as a professional IT, OT, cyber guy. I've only been doing cyber 4 years, so I'm kind of new to it. But as an embedded systems guy, I think of embedded systems all the time. I grew up doing that, right? I did 1 year of cable TV set-top boxes. I did 1 year of cardiac Dopplers. But other than that, I've done meters and protection relays or either IT stuff, right? So when I look at the stuff, cyber, I mean, it fits in really nice down at the lower levels of the protocol stack, right? And what I'm amazed at, all the products that I built in my life around metering and stuff like this, we didn't think about cybersecurity. Early on, we had a meter that if the had an optical portal in the front, in the certain time of year, if the sun hit the leaves, it could go in and modify the memory. The protocols were wide open, checksum on the end. Then we went to CRCs, and now we're in the key world, PKI and this kind of stuff, right? So one problem, the cost of security. Why does a vendor want to put security into a model when it costs? Well, one, my argument would be, I don't think they know exactly what to do. We can say, do that requirements document, but the requirements, I've read the Industrial Internet Consortium requirements document. It's beautiful. There's a NISTR 7628 document for smart grid. It's a beautiful thing. Gives you a tremendous list of requirements. IEC 62351. And when I've read through all these things, they all say the same thing. Do a really great job of security. That some go into more detail than others. But when you look around for a best practice, I don't see one. I have not seen one. I have not seen an implementation of anything I would call a best practice that you could say, vendor, please do this. So that means that every vendor, if they're doing security, they're out kind of figuring out what they think the best thing is. And then we end up with a proprietary system again, kind of thing, you know? So just real quickly, going back to a SANS conference in 2013, this is a comment that Joel just made. We, in our lab in Mount Holly, North Carolina, outside of Charlotte, you can walk into you come in with a key. If you want to get the key, you come in.
You ask the secretary, she just gives you the key.
Could get the key that way. Or pretend it's a substation. You can kind of get the key the same way for a substation. You walk in the substation. If you can get in the control house, which I'm sure you can socially engineer or figure out how to do the locksmith thing, you get in, you might find a hub. Some of the stuff is that old. You find a switch, you do a T-tap, you plug into the network, you have visibility of the network, it's all clear text, you see who the master is, the DNP3 master, the slave, you can take over, you can do lights on, out, off on. You can drive the lights, you can drive the protection relays. It's not that hard to do. So I work in this group called the Emerging Technology Office. This is the best job in the world. There are 18 of us. My boss, Jason Hanley, is over there, and my colleague, Dwayne Bradley, is sitting there. So I have to make sure I always say the right thing here when this is going on. But anyway, it's a great job in that we're doing R&D, a little bit around generation, not so much about transmission, really distribution, because the things that are driving us from a business point of view are the dynamics of the grid that is changing. Duke has about 50 gigawatts of energy to be able to push energy out. 3 of that is renewables. Renewables are coming at us fast and quick. And instead of sort of a hierarchical, big, centralized system of generation pushing out through transmission and distribution down to radials, what we're seeing is 2 flows coming back toward generation. We're seeing the proliferation of smaller distributed generation sites picking up all over the place. So in our group, we're trying to figure out what the future is going to look like and what does that system mean. If it moves from hierarchical to a hybrid decentral or completely decentral, everybody talking sideways kind of thing, then this is where we think the world is going. So what does that system look like in the future? To just sort of summarize this
Come to your presentation.
come tomorrow, but come to the presentation tomorrow and we'll go into great detail.
It's in the
But
first case study session.
from the bottom, if you work bottom up and you look at a device that was not built with security in mind, and you were going to build a new one in the future, what would the reference architecture look like? You know, how do you make that box have an identity that is secure? And then, why do I trust Joel? I'm gonna work with Joel. We're working together in the field in a microgrid. Why do I trust Joel? Why do I trust any of these guys on the panel? How do I build that into my system? Now, the only reason I scoffed slightly at the Purdue model, I didn't mean to scoff at it, really, but at the lower level, there's an argument that says, I have to run so fast in a real-time system that I cannot bother to do authentication. That is buried in the lowest level of it. I can get that. Maybe I can wrap a fence around that lower section. Maybe I can do something. We have a digital substation in our world where we say we have one control box and we have these things called merging units that are really A to D converters at the edge, and we run fiber between them. And we say, well, maybe that's secure enough, and I can put a fence around it all, and then, I don't really have to worry about authentication. But I would argue moving forward into the future, we have to understand identity, we have to understand trust, we have to build authentication into these systems. What does that spec look like? What standard are you going to follow? There is no best practice. So, thank you. That's all I wanted to say. I think it's a big problem.
Yeah.